Well, we're really excited today because we have a special guest, and Gina and I have been excited about this.
Yes,
and we have Dr. Woodbury here today, and you may know her well because of the Real Science for Kids, and I think back in the day I used one of those volumes with my kids, and actually we've been having calls about your new curriculum for months. I think it was before I even knew it
Customers have been excited.
Yeah, yes, exactly. So we want to welcome her. She has studied science in depth. She's worked in areas of biophysics and molecular biology and neuroscience. She homeschooled her kids for 14 years.
Yeah.
That's fabulous. And she founded Gravitas Publications in 2003, and she also went back to school and got her MED
Again.
in curriculum and instructional design. And she's just got a lot of research, 2 decades of research that has affected this new volumes and how children learn, right? And I'm excited about that because I didn't care for science the first time around, but as I brought my kids into this situation, that's when I really enjoyed it. So,
and it makes the difference when you're teaching your kids and you're learning alongside them, doesn't it?
Rather than just doing it myself.
And you've written all this wonderful curriculum. We have the building blocks of science and focus on, and now this lovely Real Science for Kids science.
Yeah.
And what prompted you to write these wonderful science programs?
Well, it all started because I was at a homeschool conference and my kids were growing up, and I was looking at the elementary and middle school textbooks for my kids.
Yeah.
And it dawned on me that my own struggles in high school and college were because I wasn't prepared for those courses. And in fact, when I got to college, I flunked my first chemistry test. And I had, fortunately, a friend who was from Los Alamos, and she tutored me, so I made it through. My big dream was to become an oceanographer. Turns out I get seasick, so that didn't
Funny how life
out.
changes us. Yeah.
So, and so I went ahead and got my doctorate in chemistry. And, when I started having kids, I started looking at science programs, and I started flipping through the books going, well, these were elementary books, and I'm like, where's the science? And it occurred to me that because we don't teach real science in the elementary and middle school grades, our kids enter high school and college unprepared. And one of the effects it had for me was to just crush my confidence. When I flunked that chemistry test, and I felt like I was playing catch up the next 4 years. And in fact, I really felt like I didn't understand science very well until I got to, graduate school. And then it was like, oh, all the pieces came together.
Wow.
And so when my kids were little, I wanted to write books that would help them better understand science. And so I wrote these trying to solve a problem, and that's the problem, is how do we get kids ready for high school and college level science? And so I approached it I didn't realize it was such a different way than most publishers approach science education. At the time, it just made sense to me. I wanted to ask the question, well, what do you need to know in high school to do well in college? What do you need to know in middle school to do well in high school?
So you backed down.
And then I just backed it down. And that's why these books start off with chemistry. So chemistry is foundational for all of science. And so if you look at every book table of contents, it starts with chemistry. And so it's
even in your focus on books.
Even in the focus on books. The first book I wrote was a chemistry book.
Okay.
Right? So it's what is chemistry, what are atoms, what are molecules, and it just follows the same sequence.
And that's fascinating that you can teach that in first grade, second grade, the younger years, and give them that building blocks. That makes sense.
It does.
Right.
It's actually not that hard. If you really break chemistry down, it's really only 3 things: atoms, molecules, and chemical reactions. And then all the rest of chemistry.
Too scary.
I think I can remember those.
Right.
Yeah, that's
Atoms,
awesome.
molecules, chemical reactions. And then all the rest of chemistry is just different atoms, different molecules, different types of chemical reactions. And so if you learn those 3 foundational topics, you can build all the rest of chemistry off of it.
Well, and you do make it sound so easy. And I will say that your books are written so you can understand those hard topics.
Yeah. Yeah, I wrote them for kids. So they're written in a conversational tone. I didn't like and still don't like most science textbooks. I think they're kind of boring. And I wanted the font to be kid-friendly, and I wanted all of the graphics to match the text. You know, I always found it frustrating when I'm reading a text and they have some random picture there. It's like, well, what is that picture there for?
Yeah.
So all of the images and illustrations match the text.
Yeah, could you hold that page up? That's really a neat page. Yeah, I can see what you mean by that.
The font's large, it's very accessible. You're not reading a bunch at a time. You've got small pieces to digest.
Right. And it's written in a conversational tone in that I'm just explaining to you, to the child, to the student, what is this, right? And that, I think, differentiates the program from a lot of other science programs.
And you know what I hear from parents a lot is that I don't like science. I didn't like science in school. And what I think will happen with this for parents and children is that they're going to learn alongside.
Right.
And I think that that's a real key, you know, because your kids are seeing you learn, and it's so accessible for someone who, quote, detests science, right?
Exactly. Because, you know, and that's the other reason for Real Science for Kids is most of my friends at the time were non-science folks.
And it's scary.
It's scary. I had a friend who said, you know, when she heard the word titration, it brought fear into her heart.
I understand that.
And she didn't like, many adults have trouble, you know, had trouble as kids, right? Their experience of science, particularly chemistry or physics, was negative. You know, they weren't ready for high school, and when they got there, it was already hard. And they decided to go do something else. So the Real Science for Kids is also written for the parents. All you got to do is read the book with the child and learn alongside.
So easy. That way.
And you know, I try to tell parents, you know, you don't have to have the answers. What I want to encourage parents to do is as they read the book, they may have some questions, and their kids may have some questions. And if a kid asks a question like, well, you know, why is the sky blue? I always tell them not to jump in and try to answer it, but go, you know, unless they know the answer, but to say, well, you know, I don't know, let's go find out.
Yeah.
And that makes it something that they can do together.
Sure. I love that.
Because then you're modeling how to do that process too.
Right.
And you're figuring it out, and they're watching you figure it out.
Yeah.
And so a lot of times in our culture now, we're just, you know, we've got an answer readily available to us, and you're missing that whole discovery process that you're talking about.
Yeah.
And that's the most fun of science is the discovery process, right?
Exactly.
And I love the way your books are so open and go for the parents and even for the non-science parent.
Right.
They can, you know, they know exactly what to do.
Exactly. I wanted them to be pretty simple. Like even the chapters are not that long. I mean, by book 7, I think they get heftier.
We've got book 7 right there on the bottom.
But even book 7 is approachable for your middle school or even high school student. But the idea is to just make it approachable, especially in the lower grades, so that the parent can learn alongside. And it's not. One of the challenges I found with many science books is that there's a lot of fluff in them. There's a lot of stuff in there that you don't really need. And I didn't want the books to be fluffy. So I wanted to give, you know.
We appreciate that. Coming from a non-science.
This is a no fluff zone.
This is a no fluff zone. What is the scientific method? Let's just talk about that. What are the building blocks? What is chemistry? So there's nothing in there is wasted, I guess.
So in every book, you're getting chemistry and then physics.
Right. So
how is the order on?
So it starts with chemistry. So these books have a little introduction. What is science?
Okay.
And then it goes into chemistry. There's 4 chapters of chemistry, 4 chapters of biology, 4 chapters of physics, 4 chapters of geology, and then 4 of astronomy, and then a closing chapter. So it sort of starts off, And every book has a specific theme. Like this is What is Science?
Okay.
Book 1. If we get book 2,
Yep.
Here we are.
we get book 2, it's the tools of science.
Okay.
And so then it's the chemist's toolbox,
Okay.
you know, the physicist's toolbox. Whereas this is what is chemistry? What is biology?
This is
Okay.
using science.
That's
here.
using
Oh, okay.
science.
On level
And if you look at the last chapter, it puts it all together.
Okay.
So it connects the whole, everything connects.
Everything.
All right.
Okay. And I love how you don't dump down, the vocabulary in this, and you have a page
Right.
explaining the vocabulary and
Yes,
the
I'm very
pronunciation, I guess I should say.
right. The pronunciation. I am very big on making sure the vocabulary is authentic. One of the challenges with a lot of the incumbent programs is instead of saying atom, a lot of elementary, middle school, and even middle school, but primarily elementary books will say particle.
Oh,
And yes, an atom, you could call it a particle, but it becomes confusing, right? Because then we also call protons, neutrons, and electrons subatomic particles.
Yeah.
And so this kind of confusion gets built in early in most other programs. And when they get to high school, it's like, well, this is an atom. And a kid might be, well, I thought it was just a particle. Well, what's
Right.
the difference between the particles now? And they have to unlearn that
Oh,
to
goodness.
relearn atom. And so I also give the where we can, where it's appropriate, the Latin and Greek word roots for the different words.
Oh, that's
oh,
great.
that is.
So I think it's in this book. Maybe in the book 5. But the idea behind the word atom is it means uncuttable, right?
Okay.
Atom. It's not cutting.
Not
and so
cutting.
the atom is the smallest unit that stays the same in a chemical reaction. Whereas in a nuclear reaction, you can break it up into small subatomic particles.
Okay.
And that's why you don't call it a particle. It's an atom. It has a specific meaning for chemistry,
Okay.
right? That then you have to go and learn or unlearn
Right.
in high school. So I'm
She
very,
explains
Yeah.
that.
I wish you'd been my teacher,
Right.
honestly.
so yes, I'm very careful
Okay.
about the
Yeah.
the vocabulary. You know,
That's
we,
important, though. I can see.
Yeah, we
That would
actually
be a
phrase
foundation.
everything so that it makes sense, but it doesn't compromise the integrity of the science.
And that's a really good balance to maintain, I think.
Right.
So they're reading, the parent would be reading this with the child, and then what are the next steps in a chapter?
So they read the chapter first, and then the next step is really to do the experiment. And so we don't have the experiment books here, but if you look at the older version, we can just pull one of these up.
The lab.
I've got
The lab book. The new labs are different for the science
Is that good?
series. But the idea is that now you have this information. You've read a little bit about a subject, and the next piece is to do a hands-on experiment. So do something in the kitchen lab that reinforces what you just learned. The newer experiments follow a learning progression I call RATATAZ,
Okay.
which is read, receive information,
That's
ask.
the first step.
Yeah,
Okay.
and the second step is ask questions. And
Okay.
these are questions I encourage parents to get kids to ask their own questions. So
Okay.
it's not my questions I want the kids to answer. Want
So
them,
there's really no silly question. They
there's
can
no
ask
such thing as
whatever-
a silly question.
I don't know. I could do that. But can you give us some examples of what you might encourage your kids to ask?
So like a kid might ask, why is the sky blue? And instead of jumping in and saying, well, it's Rayleigh scattering, which might be confusing.
Yeah.
You would say, well, let's think about why is the sky blue? Why do you think the sky is blue? Well, I think the sunbeams might be blue themselves. Oh, that's an interesting idea. What do
Okay.
you? And you can just start walking down that, curiosity pathway with, well, what do you think about whether you think sunbeams are actually blue? Well, yeah, well, maybe they're blue. Why don't we find out if they're blue or red or yellow? And then you can go into, studying about, wavelengths and stuff. But the idea is just to get the kids to ask any kind of question. So, for example, they might say, why do geckos, how do geckos climb on walls?
Right.
And then they come up. So that's the second piece, is just asking the questions.
Questions.
And one of the things I encourage in the labs, in the teacher's manual, is to help students know the difference between a closed question and an open-ended question.
Okay.
And I have them try to flip it. So, you know,
Do you want to give us a try at that?
yes, sure. Let's try it.
So what is a difference between those two?
So, for example, if you wanted to do a question around geckos.
Okay.
All right, so ask a question about geckos. How do geckos climb on walls? You think you can come up with a question? Or is it too much pressure?
How do they stay up there? I had a gecko
Okay.
in my house.
How do they
for
stay
a couple
up there?
years?
Did you really?
Yes, I really did. Another lifetime ago. I'm not sure, but they made a lot of noise. And it looked like they were kind of suctioned up there.
Yeah.
So they were upside down.
Right. So I would have you write the question, how do they stay up there?
Right.
That's an open-ended question,
Right.
right?
So it's more like how and why, those kinds
right.
of. Okay.
How would you rephrase it to a closed-ended question? A yes or no.
Do geckos stay up on the ceiling? Yes.
Okay. So and so you can
It's
get
just
exactly
two choices.
two choices, but you can see the difference in the kind of answer you're going to get.
Okay.
And there's not one right or wrong, right? A closed-ended question will give you a certain type of answer.
Well, that's the first step, isn't it, for a child learning?
Yes.
Because when they are first introduced to geckos, they don't know that they stay
They
on
stay
the
up.
ceiling.
Exactly.
right.
Right, or why.
That's the first
right?
step. Yeah.
Or
And
that
then
it
the
could be
next-
suction cups or
Yeah.
something. So that's what I want to encourage. This happens more in the older grades, getting the
Sure.
closed to open-ended question,
Okay,
but there's a little
sure.
instruction in the teacher's manual for how to do that.
Oh,
Okay.
wonderful.
That's great.
So that's the second step, is ask questions.
Okay.
Okay.
And then the third step is the T, test, tinker, try, right? Which is the
And that's where the
experiment
labs
piece.
come in?
Yeah, that's
Okay.
the experiment. Let's go test something. Let's
And that's
tinker
the
with
fun
it.
part for the kids.
Yeah, and I try to get, and the labs are written so that the kids there's not one right answer. Now, there's expected outcomes, but I try to get parents away from worrying about what is the right answer. I want kids to do their own discovery, their own exploration. And so the test, tinker, try portion is really for them to just, go in and make a mess. And hopefully the parents are comfortable with that.
Yeah,
love that.
there's a level of comfort with
Right.
that.
There is.
That and art also. It seems
Yeah.
like parents don't like to do that.
Right.
know.
Yeah, just put a big
mess
brown piece
part.
of paper down.
It's a big
and
deal.
Right.
Yeah. But I love that word tinker, though.
Tinker.
Yeah.
Yeah, the whole
Exploring.
That helps them explore
Yeah.
and
Yeah.
investigate and
Exactly.
discover. on
That's
their own.
that was really sort of, that's what scientists do. So everything that I've created has been with the goal of helping kids understand and learn how to do science and be ready for high school and college. But what do scientists actually do? They don't follow a recipe. Early on, you learn how to sort of follow the steps. You
Right.
follow the recipe. Maybe you read a journal article and you follow their steps exactly.
Right.
But that's just repeating somebody else's results.
Right.
Yeah.
What you really do is you go into the lab and you tinker and you play with something.
What will happen?
What will
if-
happen if? Exactly. So that's the big portion of the experiment piece. And all the experiments are designed around some aspect of tinkering or creative problem solving. And I have one experiment that's about argumentation. So how do you make a good argument around?
boy.
So that's a fifth grade one.
I
But-
like that though.
To give them a variety of all the different aspects of what doing science really means.
Yeah.
And then the next step is again, answer questions. So now you've asked some questions.
Right.
Now you go back and we ask we figure out how would we answer the question. So like your question about geckos. Do geckos stick up on the walls was your closed-ended question. And how
no.
do they stick on the wall? So that would be a good question to write down and say, okay, let's go explore how do geckos stay on walls. We know they do. We answered yes.
Yes.
But how do they do that?
Yeah.
And then that's an opportunity to go figure out how to answer that question. And if you want to look it up, it's van der Waals forces. So it's little
That's
atoms.
a quick answer to that. Yeah.
So suction cups, glue.
That goes around the whole exploring.
want you to go look
Too
that
bad
up.
we don't have your gecko.
Yeah, I don't need.
Yeah.
I need to find a gecko.
You need to find a gecko. But it is actually really cool how geckos stick on
Yes,
walls.
absolutely.
And it all has to do with atoms. That's the whole point.
Fascinating.
And that's why you're starting
Yeah.
with that.
Once you understand about atoms, it opens up a whole world, not just for chemistry, but for physics, for biology, for geology, for astronomy, everything. And then the last piece of RATATAZ is what I call tazzle, which is a makeup word. And
It's a fun word. Though.
it's a fun word, right?
I feel like doing jazz hands or
tazzle.
something.
Well,
Yeah.
it is. It's
Yeah.
talk, tell, and dazzle.
Oh, there
Okay.
you go.
Now that you've researched how geckos walk on walls,
Okay.
you are going to present that to your parent or to your sibling or to whoever,
someone
to
else.
somebody else, and you get to share what you've learned. And that's also fun, and it reinforces. And then new questions
Absolutely.
come up, and it's just
Right.
this iterative process.
Yeah.
So that's the RATATAZ experiment. And then after they finish the experiment then there's a quiz. You can do a quiz. You can do vocabulary building.
And these will be in the student workbooks, and then there's a teacher.
So the student workbook will have all the pages for the experiment. We also have a study notebook. We'll have those pages too, which is just an activity that they can do to reinforce the vocabulary, use it kind of as a vocabulary concept builder. And then it will have the quiz. And then the teacher's guide will have a lesson plan, answers for the study notebook, and the how to do the experiment. There are no answers in any of the experiments.
Okay.
And I did that on purpose.
Yeah. Yeah, I think that would
Well-
seem formidable to a lot of parents, though.
And just you explaining the RATATAZ, it makes sense. No.
Yeah. So it's a challenge. A lot of students and parents will want to go and do an experiment and get the right answer.
Yeah.
Right? Did I do it right?
Right.
And although I'm sympathetic to that feeling, because
Sure.
I'm a good student, I always want to get the A.
Get the right answer. Yeah.
Right.
Yeah. But
It-
your goal is a little different.
It's
with
different.
what you're aiming at, right?
Yeah, at the end of the day, what I really hope that Real Science for Kids will launch is, creative problem solvers. There's a lot of problems in the world that need creative solutions. And if I give students an experiment with an expected outcome, it tends to shut down that creative
Yeah.
exploration, discovery piece. It's like, well, I'm going to shoot for the right answer. Instead of feeling maybe a little frustrated that I don't know the answer, but then getting comfortable with this is the answer that I got, and this is how I'm going to present this answer. And then maybe they have a sibling that gets a different answer. It's like, well, now what do we do? Who's right? Well, we have to have a conversation.
Right.
And that's really how science is done.
Well, we talk a lot about kids stepping outside their comfort zone in order to learn and to stretch themselves
Right.
and to explore that and to get comfortable with a little bit of discomfort. And that's exactly what you're talking about.
Right. It is a little uncomfortable not knowing whether or not you've got the right answer with, an experiment but at the end of the day, science is really not about just finding the right answer. It's finding out what works. It's discovering something new, which we don't have the answer for yet.
And it's making them think creatively and outside
Exactly.
the box.
And that can be hard to translate into a curricular program. But
Right.
the more you practice it,
Yeah.
the more a parent and their child is comfortable with this is an experiment. It's actually a real science experiment where we don't really know what the expected outcome or the right answer is. We're going to go do it and we're going to see what we get. What are our conclusions? And then we can share that with somebody else, with,
Right.
another homeschool family or another student.
I'm wondering, how do you feel closure then? Do you when we've got set list of directions and things, there's a sense that, oh, I completed this.
I got it right.
I got it right. I've learned something. And what you're describing is exciting, I think, but it's also, there's this uncertainty going on too. Do you know what I mean?
Yeah, and so I would say the closure comes through your conclusions.
Okay.
What are your conclusions about this experiment? And a lot of times you're gonna find a common, like I'll do the experiment. When I was doing experiments in the lab, we would have a phrase, "in my hands." In my hands, I got this result.
Okay.
Oh, I love
Right?
that.
And
Yeah.
so in your hands,
like
you
that.
got this result. And sometimes there is, an outcome, a right answer, so to speak. And it's because I did it in my hands and I got this result. You did it in your hands and you got this result. Right?
Yeah.
There's going to be an experiment like checking for acids and bases. And they're going to use litmus paper to test for acids and bases.
Right.
And if you put litmus paper in an acid, it's going to be pink. If it's it's going to indicate that it's an acid. And if you
Right.
put it in, ammonia, it's going to indicate that it's a base. Right? So that's a right answer.
Right.
Right.
Right? But oddly, if you put it in salt, right, you might get a different answer. So I want kids to be comfortable exploring, like what happens if I add, if you put it in dish soap, some dish soap is basic if you put litmus paper in it, and some is acidic.
Yeah.
Right?
Yeah.
And I don't want to give them that answer, because if I
No,
say
that's really good.
dish soap is going to be basic and it's going to indicate a base, they'll be like, well, I got it wrong.
Number one, that's not true necessarily.
Right.
Right.
But if you
Okay.
flip over the bottle and read the ingredients,
Yeah.
some dish soap has acetic acid in it.
Okay. So
So-
it's better to go to all these different ones.
Yes.
And then what's the difference between A and
Yeah.
B and C dish soap, right?
Right. So years ago,
Okay.
I had an experiment where we were testing for carbohydrates, right? And we were using the bananas. I think it's in one of these books. We're using bananas and testing different foods, right? And I believe I had a parent that wrote in, and they were really frustrated with my experiment because it didn't work. And they tested the banana, and it didn't show any carbohydrate. And I was like, well, what was the ripeness of your banana?
Okay.
And she said, well, it was almost black. It was pretty brown.
Okay.
Well, all the carbohydrate, the long chain, had been broken up into individual sugars by then. So you're not going to detect the carbohydrate with the, the iodine, right? So she wrote back, I wrote her back, and I said, this is a great opportunity to do
I was
an
going to say,
experiment.
how fun would that be?
So take your banana, take different levels of ripeness, and then age it over the course of a week or whatever,
Yeah.
or 2 weeks, and then test
What
it each
happens
stage.
to that banana?
Yeah, and I said, you made an amazing discovery.
Right.
It's not that you got it wrong. You just didn't get the expected outcome. So with the new experiments, I'm trying to build that in,
Yeah.
where there isn't one answer. There's these are the answers that I got. This is the conclusion that I draw from that answer.
Yes. And that's a very important second step.
Yes.
To have the, what is the conclusion? Based on this information, what am I
Right.
what am I saying?
Right.
Right. Exactly.
Okay.
And I really want kids and adults to be able to say, this is the conclusion I draw from my data. So that's what scientists do.
Right.
We do something in the lab, we draw conclusions based off of our data.
Yeah.
Then we go to a conference and we compare it with somebody else.
Right.
If I'm expecting a certain outcome, then I'm going to deny all of my results because I'm not getting, the right answer. There was a guy who won the Nobel Prize. I think his name was Jim Smalley, for buckyballs. And this is a little carbon made of a soccer ball made of carbon. And what he did is all these researchers ahead of them, he was doing, I don't know, remember exactly, I think it was a gas chromatograph or something, but he was doing this analysis, and he saw this little spike at the end. And all of the previous people for decades were just ignoring this little spike at the end, thinking it was noise. On their data file, on their data profile. And he was like, well, I wonder what that is. He didn't ignore it. And he discovered
inquisitive.
buckyballs.
Wow.
Carbon
Now
soccer
I need to go
balls.
look that up.
Yeah, so
We do.
So I think that's a really important lesson, is that we don't want to just look for the right answer or the expected outcome. We really want kids to just do the experiment. This is what I got. I didn't see the carbohydrate. Oh, I did see the carbohydrate. Well, what's the difference?
And that gives me, as a homeschool parent, freedom too, because not being a science person, it's like,
Right.
well, you don't have to come up with this specific answer.
Right.
And,
Yeah.
So that's great.
It's a pleasant uncomfortableness.
Right.
I think, right?
Being comfortable with ambiguity, right?
Right.
Which is,
Well, and I think that in other subjects, I was thinking about, I have that level when I've taught people how to write compositions, because they want a formula.
Right.
And there are steps and there are patterns to take, right? But where the creativity comes in is that individual response to it and how they put these words together
Right.
and that sort of thing. So there's a lot of life that is that kind of process, right?
yeah, I think real art
Exactly.
comes out of this ability to be creative. And I think we often think of science as a non-artistic, very hard, linear field, where it's really, it's got just as much creativity as painting or sculpture, or discoveries happen because, I have this idea and I'm going to put these pieces together. But if I don't trust my own creative, skills, I'm not ever going to be able to put it together.
Well, and your books, I love the way that you have that chemistry first aspect to it and building that foundation. And I know that it probably doesn't exactly align with the next generation science standards, but it sounds like it's better. I guess it better prepares the student for the middle school and high school science in that regard.
Yeah, I mean, the way I would say it is the Real Science for Kids books follow a different map. And
Okay.
the next
I like
generation science standards and all of the incumbent materials written from them follow a different map.
So it's not that you don't cover them, but it's
We don't cover them. We do cover them, but not in the
Right.
sequence that the NGSS
Okay.
would dictate.
That's a distinctive point, though. I think you need to realize that you're getting
right. It's they're
you're getting to
there.
a similar
Right.
location.
Right.
Would you say it that way, but you're taking a different
Yeah, it's a different map.
direction to get there?
And what I would say is that the map that the NGSS and all incumbent programs use is actually old and outdated. It's using old-fashioned cognitive psychology to dictate what kids can and can't learn.
Oh,
And because it's an
that's
old and
interesting.
outdated map,
Yeah.
right, it can introduce a lot of what are called misconceptions, wrong assumptions about how things work. That when you get to high school and college, you have to undo, you have to unpack, you have to replace. Real Science for Kids doesn't follow that map. It's more of I would argue, an updated map.
okay.
It's, 21st century science. So I introduce atomic molecular theory early on
Yes.
because we know
That's-
what atomic molecular theory is now. Back in the day when the first curricular materials were built, we didn't really know what atomic molecular theory was. Even in the 1920s when some of these theories were developed, right? These learning theories were developed.
Right.
So we didn't introduce it in the elementary grades because, the adults were struggling to understand it. But now we know what it is, and we can break it down into its component parts, and we can teach atomic molecular theory starting in first grade by just breaking it into the simpler steps, right?
And I think that's what really sets your curriculum apart, because wasn't it that back in the early 1900s or whenever the psychologists came up with kind of this formula where he believed younger kids weren't able to understand that, and you made it possible in an understandable way to, I guess, give us the information.
Yeah, I didn't know at the time when I started Real Science for Kids that that's what I was doing. It just, from a scientific
kind of-
perspective, it made sense.
Okay.
If you want to learn how to play the piano or, be a composer, you start, 3, 4, 5 years old learning how to play, right? The same is true with science. If you want to understand science, you start with the building blocks of actual science.
Yes, I got it.
It didn't make sense to me why all of the elementary and middle school books started at had a different starting point.
Okay.
Until later on, until I got my master's in curriculum and instructional design, and then I was like, oh, they're using a different map. And the map is wrong. I would say the map is wrong. Now, that a lot of people would argue with me there, but it is outdated. I can at least say it's outdated and it's based off of old-fashioned cognitive science.
Okay.
There's a lot of other papers that are out there that use my approach. They just haven't been put into textbooks so much. So I don't think that I didn't know that background when I started. I was just writing a series that made sense to a scientist and works for kids.
Yeah.
But now I know that it's actually the challenge is these different maps, and how the older map actually introduces a lot of problems for kids learning science when they get into high school and college. You can see the test scores just drop in high school. You can see kids excited about science in the elementary and mid-school grades, and by the time they get to high school and college, they're like, yeah, no, I'm going to go be a journalist. You know, because they can't get over...
No offense to journalists.
Something other than a scientist. Right. Yeah, so I think that's where the problem really is. I think I didn't understand the full complexity of the problem when I started.
Yeah.
But now I see it pretty clearly. It's like, well, if you use the wrong map to get to a certain destination, you're actually not going to get there. So Real Science for Kids can map onto an NGSS program. The big difference is going to be that I introduce atoms and molecules in the elementary grades, whereas they don't. So there's going to be places where I would say we are NGSS aligned and beyond. Right?
You exceed it, right?
We exceed the NGSS.
Exceed, okay.
And it's just ordered a different way.
Now, do you recommend a family starting at book 1 then, because you have this kind of a cycle that's going through?
Yeah.
What is your recommendation?
I would say it depends on the reading level.
Okay.
So book 1 used to be grade 1. We've bumped it up to more like grade 3. The readers that we have, we're developing are for grades K through 2. And those are Lexile scored.
Right.
And they have certain, reading levels, right? But if you have a second grader who's ready for book 1 or a first grader who's reading, I would start in book 1.
Okay.
If you have a 6th or 7th grader who hasn't had a lot of science, I would start in book 5.
And this is because your books are spiraled, right?
Right.
So the information in book 5 would be like the information in book 1, only on more of a 5th grade level or a middle school level.
If you look at the chapter sequence for book 5, it's pretty much the same as book 1.
Okay.
But the sequence for 5 goes into, so you can see it says, what is science, right?
Yes.
But the sequence for 5 will go into more detail. The chapters will go into more detail.
Yeah.
But the sequence is the same.
Because we've got interpreting scientific data here where you're explaining the
Building
method.
block. Exactly.
So if you have an older student that hasn't had much science, this would be...
Yeah.
Book
You can
5,
start with book 5. However, if you had an older student that looked at book 5 and went, oh, you know what, this is already too hard for me,
Okay.
they can bump them down to book 1.
Why not, right? Yeah.
That's why I didn't give them grade levels. And even for adult learners.
I think that makes it more
know.
accessible that way too. We have a lot of families who want to have that more freedom rather than it say a specific grade.
Right, yeah.
Honestly.
Well, and I think, not everybody's at the same level.
Right.
So when I say grade 1, everybody thinks, well, this has got to be a certain age range, and it's just not.
Right.
And I was going to say, even for an adult learner who wanted to go back and pick up some science, just start with book 1. If I'm going to learn Mandarin, I'm going to have to pick up
Right.
Exactly.
book 1 in Mandarin.
How bu how.
You're right, exactly.
And then your focus on
lovely.
series will focus on one topic at a time. So you'd want to do chemistry probably first, right?
I always recommended chemistry first, then biology, and then physics, and then astronomy, geology. You can flip them. Again, I'm a chemist, so I'm a little biased, but I think chemistry should come first. partly because everything derives from that, right? Even physics, right?
Yeah.
If you're going to talk about sound, you want to talk about how, molecules are moving in air, and you're going to talk about molecules, you got to talk about atoms.
Right.
You want to talk about heat, you're going to have to talk about kinetics.
Okay.
Temperature, these can tend to be physics topics, but most of it all comes back to atoms and molecules.
Okay. So if you do want to do the focus on series and you do have multiple kids, let's say you have a 5th and 6th grader and then a 3rd grader, would you most likely then pick up the middle school series and bring the 3rd grader along?
Again, it
Or I
just
guess you
depends
could
on the
do-
reading level.
Okay.
So if you're 5th and 6th grader and you want to do focus on, if your 5th and 6th grader are good readers and not intimidated by the vocabulary, you can start in middle school chemistry. The 3rd grader, I would make sure you're not overwhelming them. So learning happens on that line between frustration and boredom, right?
Yeah.
And so
Yeah.
you want them a little bored and you need them a little frustrated. And if they're bored, they need more challenge.
Right.
If they're frustrated, they need more skill.
Right.
So that's the piece the parent has to balance.
Okay.
What you don't want to do is overwhelm them to where they shut down and don't want to do science anymore. So if you have a 3rd grader, you could bump them up to middle school chemistry, but I would just be careful about the vocabulary. I'd probably rather see everybody do elementary, all the elementary. You could blast through those in a couple of semesters, and then you could jump right into
start
book
with book
5.
one, right?
Or book 1, yeah, exactly.
Okay. Very
That's
nice.
cool. Because they're getting so much from these books anyway, and then they're starting to learn that whole process
Right.
and the RATATAZ and the
Yeah, I mean, they're really learning all the different pieces that ultimately will make them a scientist or a doctor or a veterinarian or whatever. They're going to learn the vocabulary. They're going to learn how the vocabulary connects to the concepts. They're going to learn how to RATATAZ, how to put it all together and do the experiments and discover and be comfortable with the ambiguity of their own conclusions.
Yeah,
Communicate that information to somebody else.
that's really good.
And it's not sort of locked into these, we're not trying to check boxes here,
Right.
Okay.
right?
RATATAZ. I love
Yeah.
that now. We're
Yeah.
going to be saying that all
How to
the time.
RATATAZ.
Yeah, I think jazz hands will be involved, actually.
Well,
sure.
we really thank you for coming.
Oh, yeah,
and
thank you for
visiting us
having me.
today. And
This has been
Fabulous.
fun.
you're a
Yeah.
wealth of information, and we just really appreciate your
Yeah,
time.
sure.
It's so wonderful to actually meet the author
It
of
is.
this and
What a special day.
What process you were led through
Yes.
to get
Yeah.
to this point,
It's definitely been, a passion for me in trying to get kids ready for science, and not even just those who go into STEM careers, but everybody a little more comfortable with science, right?
Right.
We, science literacy, I think, is a good goal to have for pretty much everyone.
Absolutely.
Well, and the process you described is really the learning process, I think.
Right.
It can be applied to anything.
To
Oh,
anything.
sure.
Really.
Well, and at the end of the day, you want everyone to be a self-learner, right? I have these
Yes.
tools. I know how to learn
Absolutely.
whatever it is I need to learn. And I can RATATAZ it. I can, evaluate my own little experiments and ideas and draw my own conclusions and then go share that confidently with others,
Yeah. Yeah, and we often say to parents that our ability to teach someone else or share that information well with someone else and they're getting it, that's when
Really
we
helps them
know
retain
we've
it,
learned that thing.
Right, exactly.
We understood
Right.
that.
That's a really good point.
I think they
Yeah.
make this bad assumption about, they say, well, if teachers, what is that thing? Teachers teach because they can't do or something.
Yeah.
But it's
Yeah.
not true.
No.
Teachers teach because good teachers teach well, because they really know the subject.
Right.
Yeah.
And
And they're in love with
they're
that.
in love with it, and they
Yeah.
want to be able to communicate
Yeah.
Share it and-
that to their kids. And I think, homeschool parents are some of the most passionate educators I've ever met.
Yeah.
Did you write this? Was it the focus on you came up with first? Did you write that alongside when you were homeschooling your own
Yes,
kids?
I did.
Okay.
So
That's interesting.
the middle school chemistry was level 1 chemistry.
Do we have it?
Yeah, it should be over there. That was the very first book
Okay.
I wrote, and I was homeschooling my kids.
Okay.
And I had a little teeny tiny Sony laptop, and I was waking up because I had little kids, right? I had babies.
Okay.
So I'd get up at 3 or 4 o'clock in the morning and type on this laptop, and I downloaded. Yes, this was the first one.
Okay.
I downloaded. This one
Took
right
me
here.
a while to find.
That's the 3rd edition. It's
to
been
read
expanded
chemistry.
now.
It took me a while to read it.
And I did a lot of these graphics myself.
Oh, wow.
Because I didn't have an illustrator or anything. So I would do these graphics myself. And I downloaded.
Oh, wow.
I didn't do this guy, but I did the balls. I wasn't much of an illustrator back
Good
then.
job. Wow.
I did this periodic table
Oh, my
myself.
goodness.
Okay.
And what was happening is I downloaded InDesign from Adobe, right?
Yes.
And it
Okay.
kept crashing my computer. So I would put a file up, and I would make a change, and I would save it.
Yeah.
And I would make a change, and I would save it. So it took this long time
Wow.
just to get a graphic done, and then it would crash the computer, and I'd have to reboot it.
Yeah.
But yeah, that was the first one.
You
I
labored over
believe
that one,
this
right?
is the one that I used with
Yeah.
my
Oh,
kids.
wow,
Yeah.
fun.
It's
Yeah.
a good, solid book.
Yeah.
You know.
Yeah.
And this graphic here is actually real orbitals. It's based off of wave functions, so
my.
it's not just a drawing. Just if you wanted to know that.
Absolutely, absolutely. But I love that you were inspired by teaching your children.
Yeah.
And that's
really
where all
nice.
of this came from.
Well, I just didn't want them to have to face the same struggles I faced, and I hear a lot of parents face.
Yeah.
And you know, little kids come into the world with these big dreams. And
Yeah.
our job as parents and educators is to help them achieve those dreams. And if we're not doing that, something's wrong. And a lot of little kids come in and they want to be a doctor or an astronaut or, you know, like I said, a pharmacist or scientist or discover something new. And they get to college and, you know, they get kicked out of the game because they can't do the chemistry. And it's devastating for them. And it doesn't have to be that way.
No.
You know, it's not actually that hard to teach real science. I think having a good curricular program is key.
It helps
But,
a lot.
you know, but it's pretty basic. And you just, chapter by chapter,
Yeah.
go through
Step
it.
by step.
Step by step.
Yeah.
Exactly.
Well, we appreciate it.
Yeah, thank you for
so
having me. This was
wonderful.
fun.
Yeah.
This was delightful.
Now I'm going to go RATATAZ.
Go RATATAZ.